Okay, so we're looking at inverses of linear functions. Right, so the inverse of a function, it's a very special kind of relationship. Okay, so if we have a function where f of g of x gives us just x, that means that f of x and g of x are inverses of each other. Okay, so it's kind of like with sine and inverse sine, or adding and subtracting. They undo each other, and you get back with kind of back to what you put into your function. So like if you add 4 and then take 4 away, you get back to what you started with. Same with when if you multiply by 6 and then divide by 6, it goes back to where you start. So in functions, like operations, have an inverse. And it's the function that if you put them in, you get back to what you start with, what you put in, which is just x. Okay, and we need to be able to figure out how we find these functions. And the way we do this is we solve a function for x. So we rearrange it to find x, and that gives us our inverse function. Okay, so we rearrange a function to get x equals, and this is our inverse. Okay, or kind of f to the -1 of x. Okay, so it's inverse like with sine. When we're doing the inverse sine, it's sine to the -1. It's the same for functions, that it's to the power of -1 for our function. Right, so if we start with, let's start with f of x is equal to 2x plus 1. Right, so for these we always have to say that y is equal to f of x. Okay, so that gives us that y equals 2x plus 1. And what I said, we're rearranging the function to get x equals something, and that is our inverse. Okay, so we have to take away 1 from each side, so we get y take away 1 equals 2x, get that 2x on its own. So I've taken away 1 from both sides. Then I need to divide both sides by 2 to get rid of the 2 in front of the x, because it's multiplying. We need to do the opposite to get it on its own. So we're going to get x is equal to y minus 1 divided by 2. Okay, so that means that so the inverse function of x is equal to, and then in here we need to replace the y with an x. Okay, so that's just saying if we put x minus 1 over 2 into that function f of x, we will get x as our answer. Okay, so we found the inverse for that one. I'll do another one. So if we have f of x is equal to 1/4 x plus 1, right? So we have to say that y is equal to f of x. It's the same steps for finding inverse of linear functions. Every step is always the same. So we get y is equal to 1/4 x plus 1. Right, so first thing we're going to do is get rid of that quarter by multiplying by 4. If we do something to one side, we have to do it to the other side as well. So we're going to get 4y is equal to x plus 1. And then we have to take away 1 from both sides. So we get that x is equal to 4y minus 1. So therefore, the inverse function of x is equal to 4x minus 1. Right, let's do one last one here. So we'll have f of x is equal to 3 bracket x minus 4. Okay, So again, it's y equals f of x. There's two options here. You can either multiply out the brackets and then rearrange, or you can kind of leave it as it is and rearrange that way. Doesn't really matter, you'll get the same answer either way. So I'm just going to do it this way. I'm going to divide by the 3 first. So we're going to get y over 3 is equal to x minus 4. Then we're going to add 4 to both sides, because if we do something to one side, we have to do it to the other side as well. So we get y over 3 plus 4 equals x. So therefore the inverse function is 1/3 x plus 4. Right, so that is inverse of linear functions.